16 billion miles from Earth, a machine older than the internet just sent home a message that scientists cannot fully explain. Voyager. Humanity's most distant creation has been staring into the darkness between the stars for over a decade. And what it found there was not empty space. It found heat. Violent, impossible heat. Tens of thousands of degrees, wrapped around our entire solar system like a burning wall. And here's the part nobody is talking about. The spacecraft that discovered it is now dying. NASA is racing against time to keep it alive. This is the story of Voyager's most terrifying discovery, and its final battle. In September of 1977, a rocket lifted off from Cape Canaveral carrying a machine that weighed less than a small car. Its computers held 68 kilobytes of memory, less than a single photo on your phone. Its mission was supposed to last 5 years. Nobody in that control room believed they were launching something that would outlive most of them. Nobody believed that 49 years later, this same machine would still be whispering back to Earth from a place no human technology has ever been. And absolutely nobody imagined what it would find when it got there. Because Voyager 1 was never designed to leave the solar system. It was built to photograph Jupiter and Saturn. That was the job. Take pictures, send data, go silent. But the engineers of the 1970s built something so absurdly durable that when its planetary mission ended in 1980, the spacecraft simply kept going, faster than any object humanity had ever thrown into the void, 38,000 miles per hour, heading in one direction only, out, away from the sun, away from everything we know. And for the next 3 decades, it flew through darkness, waiting for a boundary that scientists weren't even sure existed. Then on August 25th, 2012, something changed. Voyager 1's instruments detected a sudden, dramatic shift in the particles surrounding it. The steady stream of solar wind, the river of charged particles that flows outward from our sun, simply stopped. In its place came something else, something older. Particles that had been drifting between the stars for millions of years, ejected by the deaths of ancient suns long before our own star was even born. Voyager 1 had crossed the heliopause. It had left the sun's protective bubble and entered true interstellar space, the first object built by human hands to ever do so. And this is where the story stops being a triumph and starts becoming a mystery, because the boundary Voyager crossed was nothing like what scientists had predicted. For decades, textbooks described the edge of the solar system as a quiet, gradual fade, the sun's influence slowly dissolving into the calm emptiness of the galaxy, a gentle transition, a soft border. What Voyager actually found was the opposite. Its sensors recorded abrupt, violent changes in particle density and magnetic fields, not a fade, but a collision. A turbulent frontier where the solar wind slams into the interstellar medium and compresses into overlapping, chaotic layers of energized material. And buried inside that chaos was the reading that shocked everyone: temperature. As Voyager pushed through the boundary region, it measured plasma heated to staggering extremes, a superheated zone that scientists began calling the Wall of Fire. Reports based on the Voyager data describe temperatures in this region reaching tens of thousands of degrees, figures cited as high as 90,000 degrees Fahrenheit. Read that again, 90,000 degrees. Hotter than the surface of the sun itself, sitting at the edge of our solar system, in a place we always assumed was the coldest, emptiest darkness imaginable. Now, before your mind jumps to images of flames, this is where the physics gets strange. There is no fire out there. Nothing is burning. The plasma at the heliopause is so thin, so incredibly sparse, that Voyager itself passed through it unharmed. The heat is the kinetic fury of individual particles, charged fragments of matter, trapped and compressed where two cosmic forces collide, slamming into each other at tremendous energies. Think of it less like a wall of flame and more like a battlefield, the place where our sun's outward breath crashes against the pressure of the entire galaxy pushing back. A standoff that has been raging silently for billions of years, and we only just found out it exists. But here's where it gets worse, or at least stranger. Because the heat wasn't the discovery that truly disturbed the scientific community. The magnetic field was. Every model, every simulation, every theoretical paper predicted the same thing. When Voyager crossed from the sun's domain into interstellar space, the direction of the magnetic field should have changed dramatically. The sun's field and the galaxy's field come from completely different sources. They should point in different directions. That shift was supposed to be the definitive proof of crossing the border. A clean, unmistakable signature. Voyager 1 crossed. The field didn't change. The magnetic field on the outside of the heliopause was aligned, nearly parallel, with the field on the inside. At first, scientists told themselves it was a coincidence, a local anomaly, one data point from one spacecraft in one location. Maybe Voyager 1 just happened to exit through an unusual patch. There was only one way to know for sure. And it required waiting 6 more years for a second spacecraft on a completely different trajectory to reach the same boundary thousands upon thousands of miles away from where its twin had crossed. In November 2018, Voyager 2 hit the heliopause. Its magnetometer switched on its readings, and the field outside was aligned again. 2 spacecraft, 2 different exit points, separated by billions of miles, same impossible result. This was no coincidence. This was a pattern. And it means one of 2 unsettling things. Either our sun's magnetic influence reaches far deeper into interstellar space than anything in our physics predicted, or the galaxy's own magnetic field somehow bends and reshapes itself around our solar system, wrapping around our bubble like water flowing around a stone. Either way, the conclusion is the same. The boundary between our space and outside space is not the hard shell we imagined. It is porous, blended, connected. The solar system is not a sealed fortress drifting through the void. It is an open structure, and things flow across its walls in ways we do not yet understand. Think about what that means. The heliosphere is not just a scientific curiosity. It is our shield. That bubble of solar wind deflects a massive portion of galactic cosmic radiation, high-energy particles from supernovas, explosions, and dying stars that would otherwise pour into the inner solar system. Every living thing on Earth exists under the protection of that invisible barrier. And the 2 Voyagers are the only machines in human history that have ever measured it from the outside. They found it turbulent, they found it burning, they found it leaking, and they found it changing. Because in 2020, years after crossing into interstellar space, Voyager 1 detected an unexpected surge in the surrounding magnetic field, hinting that the sun's activity may occasionally push the entire boundary outward, expanding and contracting like something breathing. And then Voyager heard something. In late 2018, mission scientists announced that Voyager 1's plasma wave instrument had picked up a faint, continuous signal in the interstellar medium, a persistent vibration in the ionized gas between the stars. Constant, low drone. Scientists describe it as the ambient hum of interstellar plasma itself, the background rhythm of the galaxy, inaudible to any human ear, detectable only by an antenna floating in the dark beyond the reach of the sun. For the first time in our species' existence, we are listening to the space between the stars, and it is not silent. Every one of these discoveries came from a machine running on 1970s technology, a machine that communicates with Earth at 160 bits per second, roughly 500,000 times slower than your home internet. A machine whose signal, by the time it reaches the giant dishes of NASA's Deep Space Network, has weakened to a whisper, billions of times fainter than a watch battery. Every single data point about the wall of fire, the aligned magnetic fields, the interstellar hum, all of it traveled 16 billion miles through the dark, one fragile bit at a time. And now that machine is dying. This is the part of the story that most coverage skips, the part happening right now in 2026. Because while the discoveries made headlines, a slower, quieter crisis has been unfolding inside NASA's Jet Propulsion Laboratory. Both Voyagers are powered by radioisotope thermoelectric generators, nuclear batteries that convert the heat of decaying plutonium into electricity. There is no solar power out there. Sunlight at Voyager's distance is a faint memory. The plutonium is the heartbeat, and plutonium decays. Every single year, each spacecraft loses about 4 watts of power. 4 watts. That's less than a nightlight. But after 49 years of continuous decay, the Voyagers, which launched generating roughly 470 watts, are now scraping the bottom of their reserves. The power margins, in NASA's own words, have grown razor thin. So the engineers have been doing something that sounds almost cruel. One by one, they have been shutting their spacecraft down. Heaters, off. Backup systems, off. Science instruments that operated flawlessly for nearly half a century, off. Each shutdown is a calculated amputation. Sacrifice a limb to keep the heart beating. Voyager launched with 10 science instruments. Today, Voyager 1 has exactly 2 still running, the magnetometer and the plasma wave subsystem. 2 instruments listening alone in interstellar space, carrying the entire scientific output of humanity's most distant mission. And this year, the situation nearly collapsed entirely. On February 27, 2026, during a routine roll maneuver, a standard rotation Voyager 1 performs to calibrate its magnetometer. Something went wrong. The spacecraft's power levels dropped unexpectedly. Suddenly, engineers realized they were standing at the edge of a cliff. If power fell any further, it would trigger Voyager's undervoltage fault protection system, an automated failsafe that shuts down components on its own to save the spacecraft. That sounds helpful. It isn't. A fault protection event 16 billion miles from Earth means a long, complicated, dangerous recovery operation, with every command taking nearly a full day just to arrive. The mission's own manager compared fault protection to a safety net under a trapeze artist. It exists, but the artist should never, ever let go of the trapeze. So on April 17th, 2026, NASA made a brutal choice. They sent the kill command for one of Voyager 1's most historic instruments, the Low-Energy Charged Particles experiment, the very instrument that had helped sense the moment Voyager crossed into interstellar space. The command took 23 hours to reach the spacecraft. The shutdown itself took 3 more. An instrument that had run almost continuously for 49 years, whose internal stepper motor was tested on Earth for 250,000 steps and had faithfully executed more than 8.5 million, went dark. Its own principal investigator revealed that even after its supplemental heater was turned off and its temperature plunged to minus 62 degrees Celsius, the motor kept stepping. In his words, that his is the stuff that dreams are made of, and they had to turn it off anyway. That sacrifice bought Voyager 1 roughly 1 more year of life. 1 year. As things stand, that's the number. But NASA isn't ready to let go, and this is where the story takes its most dramatic turn. Because right now, this very summer, the Voyager team is attempting one of the riskiest engineering operations in the mission's entire history. They call it the Big Bang. Heaters must keep the propellant lines warm because if those fuel lines freeze in the deep cold of interstellar space, the spacecraft loses the ability to point its antenna at Earth. And if the antenna drifts off target, the mission ends, not with a failure of the spacecraft, but with silence. A functioning probe, still flying, still measuring, that we simply can never speak to again. The Big Bang plan involves shutting off those traditional fuel line heaters and switching on a set of alternative lower power devices to keep the lines warm instead, squeezing out every last watt, rerouting the spacecraft's dwindling lifeblood in a single coordinated operation. All at once, on a machine older than most of the engineers commanding it, across a distance where you cannot see the result of your command for 2 full days. NASA tested the procedure on Voyager 2 first, the slightly healthier twin, a little closer to Earth with a little more power to spare, through May and June of 2026. And if that gamble holds, Voyager 1's turn comes now, in July. If it succeeds, it could delay the next instrument shutdown by at least a year on each spacecraft. And there is even a chance, a real chance, that the instrument they killed in April could be switched back on. A dead instrument, resurrected 16 billion miles away. If it fails, if the fuel lines freeze, if the power dips below the threshold, if one relay built during the Nixon administration finally gives out, humanity's deepest eyes into interstellar space could close forever, mid-sentence. And the clock is ticking toward a milestone that makes all of this even more haunting. On November 18th, 2026, at 2:16 in the morning Pacific time, Voyager 1 will cross a threshold no human object has ever reached. It will be 1 full light day from Earth. 16,194,799,96 miles away. From that moment on, a radio command sent from Earth will take 24 hours to reach the spacecraft. Its reply will take another 24 to come home. The mission's project. Manager put it in the simplest, most chilling terms. Say good morning to Voyager 1 on Monday at 8 a.m., and you will hear its answer on Wednesday morning. Every conversation with our most distant creation is becoming a 2-day exchange of whispers across the dark. We are watching, in real time, a machine slip beyond the reach of human conversation. And here's the perspective that should stay with you. After 49 years of flight, after crossing the orbits of every planet, after punching through the wall of fire itself, Voyager 1 has covered just 0.027% of the distance to Proxima Centauri, the nearest star. Read that again. Not even 0.003%. The probe hasn't even reached the Oort cloud, the vast shell of icy debris still gravitationally bound to our sun, and won't for roughly another 300 years. It will take tens of thousands of years to fully exit it. Everything Voyager has discovered, the burning boundary, the impossible magnetic alignment, the hum of the galaxy, all of it happened on our own doorstep. We have not explored interstellar space, we have opened the front door and glanced outside. And what we glimpsed contradicted our best theories. That is the real weight of Voyager's discovery. It's not just that the edge of the solar system is hot, or turbulent, or strange. It's that our fundamental picture of where we live was wrong, and the only 2 machines capable of correcting it are running out of time. Once the Voyagers go silent, there's nothing behind them. No replacement mission is en route to the heliopause. Anything launched today would take decades to reach where the Voyagers are now. When their generators finally fade, and NASA's own estimates suggest the end could come within the next few years, even with every trick and sacrifice, humanity will lose its only direct connection to interstellar space, possibly for a generation or more. The data stops, the questions don't, because the questions are only multiplying. Why do the magnetic fields align across a boundary that should divide them? How far does the sun's influence truly reach? What is driving the pressure fronts Voyager detected rippling through the interstellar medium? Is the wall of fire a stable structure, or does it shift, thin, and breach in ways that could one day matter to everything living inside the bubble? Every one of these questions has a single source of answers. 2 aging machines whispering at 160 bits per second, losing 4 watts a year, 1 botched maneuver away from silence. And yet, even the ending has an ending that outlasts us. Both Voyagers carry the golden record: sounds of Earth, greetings in dozens of languages, music, the heartbeat of a human being, a message in a bottle thrown into the cosmic ocean. Long after their transmitters die, the spacecraft themselves will keep going. In roughly 40,000 years, Voyager 1 will drift within about 1.5 light years of another star. It will still be intact. Space is empty enough, and the spacecraft is moving fast enough that these 2 machines may outlast the Earth itself. Silent ambassadors carrying proof that, for one brief moment, a species on a small blue planet looked up, built something with 68 kilobytes of memory, and threw it at the stars. So this summer, watch closely. Somewhere in a control room in California, engineers are preparing to send a command that will take a full day to arrive at a spacecraft none of them can see, built by people most of them never met, to perform a maneuver that has never been attempted at this distance. If it works, the mission that redefined the edge of our world gets one more chance to keep listening. If it doesn't, the last thing Voyager 1 will have told us is this: the boundary of our solar system is burning, the walls of our cosmic home are stranger than we believed, and the galaxy outside is humming a song we only just learned how to hear. The question is no longer whether Voyager will fall silent. It will. The question is what it will manage to tell us before it does, and whether we will ever send anything out there to finish the conversation it started. Because right now, at the edge of everything we know, there's a wall of fire, a magnetic mystery, and a 49-year-old machine standing alone against the dark. And its time is almost up.